This is the Algebra 1 video for section 1.4. It's the intro video. We're going to be looking at adding real numbers and some properties of addition. So we'll just do a couple of examples here before we look at the properties. So take a look here at number 1. The instructions are to add, and we can see that we've got -1 plus -5. So one of the ways that people learn these, and I think this is a good place to start, is to use a number line to help us, and think of these integers as directions on the number line. So we always start at 0 when we're doing something like this, and so -1 would mean to go left 1. Left 1 on the number line. The negative means to go left. If a number were positive, it would mean to go right. So -1 means to go left. So I'm going to start right here at 0, and I'm going to go left 1. And then I'm supposed to add to that -5. Well, -5 means to go left 5. So from that -1, I'm going to go left. I'm going to go 1, 2, 3, 4, 5. I'm going to end up right there at -6, and so we would say that -1 plus -5 is -6. There's another way to think about this, and I think eventually this is probably a better way to think about it than having to draw a number line every time you come into these types of questions. The concept down here below, if you are adding numbers with the same sign, what we do is we add the absolute values and we keep the sign. So if we were to rethink about this one here, -1 plus -5, we would look at those two numbers and we'd say, well, those two numbers have the same sign. They're both negative. The absolute value of 1 is 1, and the absolute value of -5 is 5. So we'd add those up and we'd keep the sign. Well, the sign of both was negative, so we'll put that negative right there. 1 plus 5 is 6. That gives us -6. As far as thinking about it, that's a more efficient way than drawing a number line. And at this point, I want you to do what you need to do in order to get these correct and understand what's actually happening. But we do want you to kind of land on that concept eventually. Let's take a look at our next question. So with number 3, once again, the instructions are to add. But this time we can see that the numbers don't all have the same sign like they did in number 1. And so we'll still use the number line, or we can use the number line. We'll start at 0 just like we did before. -7 means to go left 7 on the number line. So that's what I'm going to do. I'm going to go left over here. So after I do that, I'm at -7. And then +9, well, of course, that's a positive 9. So that means to go right 9. So from where we were before, we're going to go right 9. So I'm going to go back to the right 9, where I end up right there. Oh, I'm at 2. Excuse me. And then finally, we get to plus -5. Of course, that means go left 5. So from that 2, I'm going to go left 5. So I'll end up right there at -3. So we would say that our answer to this, our evaluation on this, is -3. As you can imagine, there is an easier way to do this, or a less involved way with the number line and all that. And that's this concept down here. So the concept is this: if you're adding numbers with opposite signs, you subtract the smaller absolute value from the larger absolute value, and you keep the sign of the larger number. So let's rethink about that first one with that concept. So -7 plus 9 plus -5. Well, I look at those first two numbers, and they are opposite signed, right? I got -7 and +9. So looking at those two numbers, the larger absolute value, of course, is the 9. And so what we're going to do is we're going to subtract the smaller from the larger. So 9 minus 7 is 2. We'll keep the sign of the larger. Well, the larger number was positive, so we'll leave that to be positive. We still have this plus -5 right here. Once again, we have opposite sign numbers. We've got a +2 and a -5. This time the negative number has the larger absolute value. The larger absolute value is 5. The smaller absolute value is 2. So I'd go 5 minus 2 is 3. but I'd keep the sign of the larger number, and that was the -5. So -3 would be our final answer. You can see that it's the same answer as what we got with the number line. But like I said, perhaps a more efficient way, a way that I'd want you to end up thinking about once you get this concept figured out. All right, we'll look at our properties next, and we'll be done. All right, the properties of addition, I'm just going to kind of lay these out here for you, and we'll practice them when we get to class. The commutative property of addition, hopefully you see the word commute in there. Of course, commute means to just change location. So a real basic illustration of the commutative property of addition would be to say that A plus B is the exact same thing as B plus A. I think we know that from before, that 2 plus 5 is the same thing as 5 plus 2. That's called the commutative property of addition, and it comes from the idea that commuting means to change location. Associative property of addition looks like this. Parentheses, A plus B, close parentheses, plus C is the exact same thing as A plus, and then the parentheses around the B plus C. So in other words, you can group addition in whichever way you want, and it's not going to affect the value of the expression. All right, the identity property of addition is this property right here. A plus 0 is equal to A. So 0 is called the identity element because any number plus 0 is itself. And finally, the inverse property of addition looks like this. A plus -A is equal to 0. So if you add a number to its opposite, you will always get 0. I think these are all pretty intuitive properties. The focus is going to be making sure that you can remember the name, and we'll use all these properties in Chapter 2 when we get on to solving equations. All right, hope that worked for you. See you in class.